Hi, this is Professor David Farina. In today's lecture, we're going to be discussing the terrestrial planets, the surface of Mercury. Let's get started. So at first glance, looking at the planet Mercury, you might think you're looking at the moon. Mercury is in so many ways like our moon that from the untrained eye, many people probably could be convinced that this is in fact our moon. The question is, why does it look so much like our moon? And that's right, it has to do with the fact that Mercury is an airless world. In other words, because of the lack of atmosphere, the interaction with Mercury and outer space and impactors such as asteroids and comets and meteorites causes the planet Mercury to be pummeled and cratered on its surface. Because of the lack of atmosphere, it also does not have any sort of weather processes to erase these craters, and as a result, its surface is peppered with craters that have been forming since the early parts of the solar system. Now that we've discussed the reasons why Mercury's surface looks the way it does, let's discuss a little more about what these surface features are and what they look like. Now, the picture you're looking at here is from the Messenger mission, which includes some very high-resolution data that was taken in very recent times. On the planet Mercury, we can find that we have these very distinctive features, these scarps or cliffs that are several hundred kilometers long and up to 3 kilometers high. We think this has to do with the way in which the planet shrank as it got cooler. And if you think about a ball, like the planet, as it cools, it starts to harden. And as it hardens, it shrinks. As it shrinks, the size of the planet is going to get smaller, and the surface is going to kind of overlap on itself, like my fingers are doing here. So we start off as a ball, and as it shrinks, it gets smaller and smaller and smaller. And as you can see, my fingers on the top here are kind of like the top part of this scarp, where one part is sliding over the top of the other. Now, an interesting part of the way in which cratering works is we can use a process called relative dating to understand the approximate age of the craters and their surrounding craters, and also the age of the scarp that we can see in this image. In other words, by knowing the rate of cratering in our solar system, due to the impact of planetesimals and the early states of our solar system, we can see the age of this scarp is, of course, younger than the age of the crater that was formed. So the crater was formed first, then the planet shrank in size. Same for this one here. Notice this one, however, this crater here is covered up, and there's no crater on the other side, and therefore the crater must be older in this case now. This crater is older also than this scarp is, and the scarp has covered it up almost completely. Now, if we had a crater over the top of the scarp that is not showing that effect, we might find that that crater was younger than the scarp. So it's an interesting ability for scientists to kind of get an understanding of age, and it's very helpful in understanding planetary processes. Now, the biggest of these impactors is known as the Caloris Basin. The Caloris Basin is a huge impact, and as you can see by the scale of Mercury here being the curvature of Mercury, you can see the Caloris Basin is representing an enormous portion of this planet. And it's got these concentric mountain ranges that form rings of various different elevations as a result of this very large impact. Now, the internal structure of each of these planets I'm going to show a number of times throughout these lectures, and I want you to always consider how each of these worlds is in terms of its internal structure compared to the Earth. So let's look at Mercury for a moment. Here is Mercury. Now, compared to Earth, you'll notice that Earth has a very large core and a relatively large mantle. Mars has a pretty good balance. It's pretty similar to the Earth in many ways. It's got a decent sized core compared to its mantle size. Mercury, on the other hand, you'll notice has a very large core compared to its mantle. Now, there are some different thoughts on why this could be the case, but one of the reasons for this could be that Mercury suffered a very large glancing impact in the past, and that its mantle was somehow removed from the planet by a very large impact. It's not known exactly if this did occur, but given the proximity of Mercury to the Sun, it's possible that that other planetary body then ended up into our Sun and being lost forever. So that's an interesting concept to consider, that Mercury may have been a larger world in the past and was fractured and broken, but it does remain that it includes a very, very large inner core that other planets in the inner solar system do not have. So thanks for watching today's video on the terrestrial planets, the surface of Mercury. If you like this video, please click that like button. If you'd like to learn more, please hit subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks again, and have a great rest of your day.